All right, today we are going to talk about simplifying rational expressions. So before we start with this, let's talk about what a rational is in general. So we're going to talk about rational numbers first. Rational number is a ratio of two integers. So I have four examples up here. We're going to get the same type of expression when we look at a rational expression. Rational expression is the ratio of two polynomials. So we end up with things that look like this. We still have our fraction bar, but our numerator is now a polynomial as well as our denominator. And what we're going to see is we can do the same things that we did with rational numbers with these rational expressions. So we can add them, subtract them, multiply them, divide them. And where we're going to start today, we can simplify them. Because let's look at this rational number here, this 25 over 5. We wouldn't leave this like this as our answer. We would write the answer is 5. Now, why is the answer 5? The answer is 5 because if we look for common factors here, 25 is 5 times 5. 5 is 5 times 1, and once I get those multiplications in there, I can cancel things on the top and the bottom of this division bar because multiplication and division are opposites, which leaves me 5 over 1, which is how I got my answer of 5. I'm going to be able to do the same thing with my rational expressions, but I need to get rid of these additions in between all these terms, and to do that, we need to do what we were practicing yesterday. We're going to have to factor all these things so that we can get multiplications in between the pieces of them, and we can cancel the like factors. So a little bit more practice with numbers so we can see where some of our errors might lie in this. So we're going to simplify 10 over 30. So factors of 10, 5 times 2. Are there any common factors in the bottom for 30? 5. So 5 is a common factor of 30. 5 times what? Well, normally we'd say 5 times 6, but 6 is also 3 times 2. So when we go through and we would write this out, now that these have multiplications in here, this 5 will cancel, this 2 will cancel. So then what's left over here? Well, we have a 3 on the bottom. What's left on the top? Well, one of the things we commonly forget is when everything cancels out on either numerator or the denominator, there's always a multiplication of 1 left there. We can put the 1 back on top, so this is 1/3. One of the more common errors that we'll see when we go through and we do this, it's something that we wouldn't make the mistake of with numbers, but we will with the expressions more often. So 5 plus 5 over 5 plus 25. Can I do that? I can't. Cannot do that because that plus is inside parentheses here. What that plus means, being inside those parentheses, parentheses tell me that I need to do this operation first. So this is really 10 over 30. Had I canceled these out first, I would have had 5 over 25, which does not give me the 1/3 that I know the answer is. Since they're not the same, that means I can't do that first. I have to add those numbers to be able to find the common factors like we did here and cancel. So let's try this with a rational expression here. So first step, we're going to factor, and then we're going to cancel out the entire factors from the top and the bottom, okay? So if we go through and we factor this, this is the difference of two squares. So this is going to be x plus 3, x minus 3. The bottom of this thing is x plus 3, x plus 3 when you go to factor it. So when we have that, when we go to factor this, how do we factor these out? Because now that we have x's in here and everything else, we tend to get a little bit more confused. The correct way to factor this is you've got to factor the whole set of parentheses out, meaning that the x plus 3 and the x plus 3 right here will cancel out because the whole set, including the parentheses, is the same on top and bottom. So that means the correct answer that we would get for this would be x minus 3, x plus 3. What we don't want to have happen is we don't want to try something like this where we just cancel either the plus 3s or just the x's and get something else left over. It's always got to be everything inside the parentheses, okay? Let's practice a few of these. So first step is always going to be factor. So the bottom of this is the difference of two squares. So that's x plus 2, x minus 2. If we go to factor this, well, the leading coefficient here is 1. So I can use that trick that we talked about when we reviewed this before. Factors of 4 that add to 4. That's x plus 2, x plus 2, because 2 and 2 add to 4. Now what we see is, just like we had in the last slide, this x plus 2 and this x plus 2 are exactly the same. The whole thing inside the parentheses and all that cancels. And that means that I have x plus 2 on the top and x minus 2 on the bottom, and that's it, I'm done. I can't cancel anything else inside these parentheses because there's no more multiplications left. Now, one of the things as we go through and simplify these, when we say factor, we always think of these factoring like we reviewed. When we get a problem like this, it's a little bit more challenging with that because this is an easier factoring. This is common factoring first, okay? So what does 10v and 40 have in common? They both have a factor of 10 in common. So if I pull that factor of 10 out, that's what I'm end up with. Now if we're here, 8v squared and 32v, well, they have an 8 in common, and they also both have this v. If I factor that out of both of them, 8 leaves me, 8 and the v gone leaves me just a v, and 32 divided by 8 is 4, and it doesn't have a v anymore because we took the v out front with it. Now, the v plus 4 cancels. We end up with 10 over 8v, but we got to be careful because now we got to look at these numbers because this is a multiplication, so I can still cancel the constants on top and bottom. So 10 and 8 have a common factor of 2. So this is 5 over 4v because the common factor of 2 cancels out. Last one, probably the toughest one because we still want to factor stuff, but all of these things are being multiplied. So that means I don't have to factor anything. I can just cancel things that are common in both the top and the bottom. So when we go to cancel here, 20 and 25. They have a common factor of 5. So that's going to be 4 and 5. There's x to the third and x. Now what we need to remember about these things to the power of this is x times x times x. So what will happen here is this x will cancel one of those, meaning that in the top we're only going to have x squared left over. Same thing's going to happen here. This y will cancel one of those, and it's going to leave us y to the third. Z to the first, z to the first, those are going to completely cancel. So when we get done with this, we're going to have 4x squared over 5, the x is gone, y to the third. And that's all there is left with that one. Nothing else will cancel out of that. So lots of practice. Most important part of this is factoring. Can't do any of the operations after unless we can factor. So make sure you practice and let me know if you need help.